We are starting with exercise 18H. Okay. So prior to this, we know this two formulae, that is limit x approaching 0 sin x upon x is equal to 1, and limit x approaching 0 tan x upon x is 1. Okay. So these are trigonometric limits, right? So just a second. Okay. And how we solve problems with respect to this is like whatever value is there of the angle in radians, the same value should be down for sine and tan. Okay. So this gets applicable only for the formula for sine and tan. Okay. And obviously x should approach 0. X cannot approach any other number. Fine. So let us go ahead with the first problem. Question number 1. Limit x approaching pi 1 plus cos x minus pi, 1 plus cos x minus pi. Okay. Now see guys, if we put the value of x as pi over here, so it will be pi minus pi, which is 0 in the denominator, and anything upon 0 is not defined. Okay. So we have to learn something new over here, which is called as changing limits. Okay. This concept is applicable for exclusively for this particular exercise, right? So what I'll do is I'll assume let x is equal to pi plus h. Okay. Let x is equal to pi plus h. Fine. So okay, so x is equal to pi plus h. Now as x approaches pi, okay, see x is approaching pi, okay, x is approaching pi and x is pi plus h. Okay, so as x becomes pi, as x becomes pi, okay, that means as x is approaching pi or very near to pi, so pi and pi will get cancelled, h will approach 0. H will approach 0. Okay, so this thing you need to remember. Fine. So this is how it works. So this can be written as limit h approaching 0, 1 plus cos pi plus h. Okay, x is nothing but pi plus h minus pi. Fine. So from x we have moved on to h. Now see, pi and pi will get cancelled. Okay. Now cos pi plus h. We have to apply all silver teacups. Okay. So I'll show you cos pi plus h. Now pi is 180 degrees. You all know that, right? 180 degrees is over here. Plus indicates anti-clockwise direction in this direction. So in this particular quadrant, your cos is negative. Okay. And 180 was at x-axis, so cos remains cos. So cos h. So cos pi plus h is nothing but minus cos h. So what I'm going to do is I'm going to replace this cos plus pi plus h with minus cos h. Okay. Okay. And this 1 plus will remain as it is. So next step, limit h approaching 0, 1 minus cos h upon h, right? Fine. So now see, we know the half angle formula for 1 minus cos 2x. 1 minus cos 2x, the half angle formula is 2 sine square x. Okay. So try and understand this. What will be the formula for 1 minus cos 2h? Okay, so it will be 2 sine square h. What is happening over here is 2x is halved over here. So we are dividing 2x by 2, so it becomes x. So 2h will be h, right? But then in our problem, we are not having h, we are not having 2h, we are having h over here. Okay, so 1 minus cos h is equal to 2 sine square. Half of h will be h by 2. 2 sine square h by 2. Okay. So this is limit h approaching 0, 2 sine square h by 2 upon h. Okay. Now see, um, the number of trigonometric functions in the numerator are 2, because there are two sines, sine h by 2 into sine h by 2, and down we are having only one h. Okay. So we'll separate the sign in the numerator. Okay. So limit h approaching 0, 2 sine h by 2 into h by 2, and down there is only one h. Down there is only one h, so we have to give this h to any one of the sign. We cannot give it to both because there is only one h. Fine. So this will remain as it is. Now if at all you remember, the angle over here is h by 2. It should be in radians, so I'm dividing by 2 and I'm multiplying with 2 into sine h by 2. Okay. Fine. Now limit x approaching 0, sine x upon x is equal to 1. Okay. So limit h approaching 0, sine h by 2 upon h by 2 will be 1. Okay. So 2 is a constant that will remain as it is. This blue colored part, the answer is 1 into 1 upon 2. How this 1 upon 2 appears over here is this 2. Okay. And here for this sine h by 2, just put the value of h as 0. Okay. So this is what we got. Now this 2 and 2 will get cancelled. So this is equal to sine 0. So the answer is 0 for this particular problem. Fine. Okay. So this was the first problem. You can go through the recording once again, as in by going back to the start of the problem. Let us go to the second problem. Second problem says limit x approaching pi by 2. Okay. 1 plus cos 2x upon pi minus 2x the whole square. Fine. So now see, um, if you put pi by 2 over here, so pi minus 2 into pi by 2 the whole square. So 2 2 will get cancelled. Pi minus pi 0, 0 square is 0. Fine. So let's apply changing limits. Let x is equal to pi by 2, whatever the value is there, plus h. Let it be some value more than pi by 2. So that value is h, which is slightly more than pi by 2. Okay. So as x approaches pi by 2. Okay. So here x is equal to pi by 2 plus h. When x is very near to pi by 2, okay, so h will be 0. So h will be very near to 0. So h approaches 0, right? So wherever there is x in the problem, wherever there is x in the problem, I'm going to put pi by 2 plus h, right? So next step, limit x, it's h, sorry, h approaching 0, 1 plus cos 2 into pi by 2 plus h, okay, upon pi minus 2 into pi by 2 plus h the whole square. Pi minus 2 into pi by 2 plus h the whole square. Okay. So limit x h approaching 0, 2 into pi by 2 will give you pi, and this will be plus 2h. Okay. And this will be 2 minus 2 pi by 2 minus 2h the whole square. Fine. I multiplied the minus 2 inside. Fine. So this 2 and 2 is getting cancelled, and we are left with pi. So pi and pi will also get cancelled. Pi minus pi 0, 0 minus 2h. within the box bracket down. Okay, now see this part I'm going to apply all silver teacups. This pi is 180 degrees, plus is anti-clockwise direction. Okay, so in this particular quadrant your cos is negative. Okay, cos is negative, and since 180 is on the x-axis, cos remains cos. So we are left with cos minus cos 2h. So the value of cos pi plus 2h is minus cos 2h. So that I'll use in the next step. Okay, so limit h approaching 0, 1 minus cos 2h upon minus 2h the whole square. Limit h approaching 0 to, see, 1 minus cos 2h, the formula is 2 sine square h, right? This is the half angle formula. Okay, so 2h becomes h. So 2 sine square h upon 4h square. Down I'm just squaring this term. So 2 upon 4, that is half. Okay. Now there are two trigonometric functions in the numerator, sin h into sin h. And down also there are 2h. So we'll just group this under the same square. Okay. Now we have limit h approaching 0, sin h upon h. So we can apply the formula limit approaching 0, sin x upon x, which is equal to 1. So this will be half into 1 square, which is half. Okay, so this half is remaining as it is. Sin h upon h is 0. That is 1. 1 square is 1. Fine. So that's how we complete the second problem. 1 square into half, that is half. Fine. Next problem. Okay, let us go to the third problem. Limit x approaching 0, 1 minus sin x upon pi by 2 minus x, the whole square. The whole square. Okay. So now x is approaching pi by 2. I'm sorry for that. Okay. So sin x term is there, but then x is approaching pi by 2. So sin x term ideally requires sin x upon x, right? And x should be approaching 0. That those things are not there. And moreover, if you put pi by 2 over here in x, so pi by 2 minus pi by 2 is 0. 0 in the denominator, everything will be undefined. Okay, so let x is equal to pi by 2 plus h. X is approaching pi by 2. Okay, as x approaches or x tends towards pi by 2, as x becomes pi by 2. Okay, so when x becomes pi by 2, so pi by 2 cancel. H will be 0 or very near to 0, approximately 0, right? Okay, so this process is called as changing limits. So what we'll do is wherever there is x, I'm going to put pi by 2 plus h. So down also pi by 2 minus pi by 2 plus h, the whole square, right? So this is equal to limit. I did not write h approaching 0. It should be h approaching 0 over here, right? So h approaching 0, 1 minus. Okay. Now sine pi by 2. Pi by 2 is up, plus is anti-clockwise direction, right? In this quadrant, your sign is positive. Okay, sign is positive, and we are on the y-axis this time. 90, pi by 2 is 90. Okay, it's on the y-axis, so on the y-axis sign changes to cos, so we'll be left with cos h. So the value of this entire thing is plus cos h. Fine. So 1 minus cos h. Okay, down it will be pi by 2 minus pi by 2 minus h the whole square. So pi by 2 gets cancelled. 1 minus cos h. Okay, upon minus h the whole square. Minus h the whole square is h square. So this is equal to limit h approaching 0, 1 minus cos h upon h square. Minus with the square. This minus is getting eliminated because of the square. So we'll have just h square. Okay. Now see 1 minus cos 2h is equal to 2 sine square h. So 1 minus cos h. So the half angle for h will be h by 2. So 2 sine square h by 2. Right? So this will be limit h approaching 0, 2 sine square h by 2, h square. Okay. Now we have a square in the numerator, square in the denominator. So that's good for both the trigonometric functions, that is sine and sine. There are two signs in the numerator. So we'll group this square. 2 remains as it is. So limit h approaching 0, 2 remains as it is. Then 2 sine square h by 2. So sine h by 2 upon h the whole square. We are grouping the square terms. Square terms, we are just taking it together. Okay. Now in the numerator we are having h by 2. So in the denominator also we should have h by 2. Limit h by 2, h approaching 0, 2 into h by 2, h by 2 into 2, the whole square. Right. So sine h by 2 upon h by 2. Sine h by 2 upon h by 2, h is approaching 0, will give you 1 as per the formula. 2 into 1 square into 1 upon 2 square. 2 will have a square along with it. So this is equal to 1 upon 2. The answer. Fine. We will proceed ahead. Question number 4. Limit x approaching pi by 2 cos x, pi by 2 minus x in the denominator. Okay, if we put pi by 2 over here, pi by 2 minus pi by 2 is 0. Anything upon 0 is not defined. So let x is equal to pi by 2 plus h. Okay, some value more than pi by 2. Okay, slightly more than pi by 2. As x approaches pi by 2, when x is becoming pi by 2 over here, so pi by 2 is equal to pi by 2 plus h. Okay, so pi by 2 getting cancelled. H approaches 0. Fine. This process is called as changing limits. So wherever there is x, put pi by 2 plus h. Limit h approaching 0 cos pi by 2 plus h upon pi by 2 minus pi by 2 plus h, the round bracket over here, because there is a minus sign. Fine. So what we are going to do is, all silver teacups we are going to apply in the numerator. Pi by 2 is 90 degrees, plus is anti-clockwise direction. So in this particular quadrant, your h is, your cos is negative, and since we are on the x-axis, pi by 2 is 90, cos changes to sine, so this will be sine h. Okay, minus sine h. Okay, so numerator will become minus sine h. Limit h approaching 0 minus sine h upon minus h. Fine, because this will become pi by 2 minus pi by 2 minus h, pi by 2 gone, and we'll be left with minus sign in the denominator. Now limit h approaching 0, sin h upon h is 1, minus minus will get cancelled, so the answer remains 1. Answer remains 1. Okay. Question number 5. Limit x approaching pi by 2. Okay. 1 minus sin x upon 2 minus pi minus 2x the whole square. Okay. If you put pi by 2 over here, it will be pi minus 2 pi by 2. 2 will get cancelled. Pi minus pi is 0. 0 in the denominator will make it not defined. So let x is equal to pi by 2 plus h. We are changing the limits. Okay. As x approaches pi by 2, h will approach 0. Change x with pi by 2 plus h. So limit h approaching 0, 1 minus sine pi by 2 plus h upon pi minus 2 pi by 2 plus h the whole square. Fine. So we'll calculate this using all silver teacups. Cos pi sine pi by 2 plus h, right? So we have all done over here. Sine pi by 2 plus h is plus cos h. You can try it once again on your own. So this will become limit h approaching 0, 1 minus cos h, down, multiply 2 with both, open the round bracket, okay, and then 2 2 will get cancelled, pi pi will get cancelled, so we are left with minus 2h the whole square. So next slide, limit h approaching 0, 1 minus cos h upon 4h square, okay, because minus 2 square is plus 4 and h will also have a square, that is h square, right? So limit h approaching 0, 1 minus cos 2h is equal to 2 sine square h, 2 sine square h, okay, half angle formula. Then 1 minus cos h will be 2 sine square, half angle of h is h by 2, 2 sine square h by 2 upon 4h square, okay. So this 2 upon 4 will be half, this will be half, and the square terms I'll just group it, sine h by 2 upon h the whole square. Now observe, we are having h by 2 over here, so down also we need an h by 2, okay. So limit h approaching 0, 1 by 2 sine h by 2, we are just having h as of now, so h by 2 into 2, so divide and multiply by 2 in the denominator, sine h by 2 upon h by 2, sine h by 2 upon h by 2 is 1, since h is approaching 0, okay, since h is approaching 0, right? So this will be 1, 1 square, this is 1, right? Square along with the square, and down it will be 2 square, 2 along with the square will be 2 square, so the answer will be 1 upon 8, right? Question number 6. Question number 6. Limit x approaching towards pi, 1 minus sine x by 2 pi minus x the whole square. Okay, let x is equal to pi plus h. See, when we put x as pi over here, pi minus pi is 0. 0 square is 0. So we are changing the limits. As x approaches pi, h will approach 0. When x becomes pi, okay, so pi will get cancelled. H will approach 0. Fine. So wherever there is x, let's put pi plus h, sine pi plus h upon 2, pi minus pi plus h, put a round bracket and then put a square to it. Okay, now here I'll just split. I'll write this as pi by 2 plus h by 2. I'll split the numerator into two parts. So this is equal to limit h approaching 0, 1 minus sine pi by 2 plus h by 2 divided by pi minus pi minus h the whole square. So pi will get cancelled. Minus h the whole square. The square of minus h is h square. Okay. Now pi by 2 is over here. 90 degrees plus anti-clockwise direction. In this quadrant, your sign is positive. So this is positive. And since we are on the y-axis, sign changes to cos. So cos h by 2, because the angle is h by 2 over here, the theta is h by 2 upon h square. Okay, now 1 minus cos 2h is equal to sine square h. So 1 minus cos h by 2. 1 minus cos h by 2 is equal to 2 sine square h by 4. Okay, see, if 2h becomes h by half angle, so the half of h by 2 is h by 4. H by 4, h by 2 divided by 2. H by 2 into 1 by 2, which is h by 4. Fine. So that is how it is. So instead of 1 minus cos h by 2, I'll write 2 sine square h by 4. Okay. So this is equal to limit h approaching 0, 2 sine square h by 4 upon h. Okay. Upon h square. Right. Down we are having h square. Let's group the square terms. 2 sine h by 4 upon h the whole square, limit h approaching 0, 2 sine, I'll write this on the next page. Limit h approaching 0, 2 sine h by 2 upon h by 4, sorry, h by 4. So I'll multiply and divide this h with 4, because the angle of sine is h by 4, so down also we need h by 4. So we'll just write h by 4 into 4 and everything within a square. Okay, so sine h by 4 upon h by 4 is nothing but 1, because h is approaching 0. So limit h approaching 0, 2 into 1 square into 1 upon 4 square. 4 will also get a square. So 2 upon 16, 1 upon 8. That is your final answer. Okay. So that was question number 6 for you all. Okay. Let us go to question number 7. Let us go to question number 7. Okay, limit x approaching 1, 1 minus 1 by x, sine pi x minus 1. Okay, so let x is equal to 1 plus h. As x approaches 1, h will approach 0. See why we are putting this changing limits concept over here is because when we put this x as 1, 1 minus 1 0, sine 0 will be 0. Okay, 0 in the denominator. So this is limit h approaching 1. See, when x is becoming 1, x is becoming 1, 1 and 1 will get cancelled, h will be 0. So wherever there is x, I'm putting 1 plus h. 1 minus 1 upon 1 plus h, sine pi 1 plus h minus 1. In the numerator, I'll just take LCM. Limit h approaching 0, 1 plus h will go over here into 1, that is 1 plus h minus 1. 1 plus h minus 1 upon 1 plus h. Denominator, this 1 and 1 is getting cancelled, so we are getting pi h. So denominator we are getting pi h, right? So limit h approaching 0, h upon 1 plus h divided by sine pi h. Okay, so this particular line is division, fine, divided by sine pi h. So limit h approaching 0, h upon 1 plus h upon into 1 upon sine pi h. Okay, the angle over here is pi h, so we'll multiply and divide with pi h. Fine. So limit h approaching 0, h upon 1 plus h, 1 upon sine pi h, down pi h into pi h. Multiply and divide by pi h in the denominator, so that for sine we can apply the formula. Now sine pi h upon pi h is approaching 0. Okay, it will give us 1. Okay, at the same time this h and this h is getting cancelled, so we can write 1 upon 1 plus 0, this became 0 over here, into 1 upon 1 into pi, this pi is over here. Fine. Okay, so this is 1 upon pi, because 1 plus 0 is 1, 1 into this pi is pi. Okay, so 1 upon pi is the answer. Let us go to question number 8. Question number 8, limit x approaching a, sin x minus sin a upon root x minus root a. Root x minus root a. Okay, if we put a as x over here, so root a minus root a will be 0. Let x is equal to a plus h. Limit, okay, sorry, as x approaches a, as x becomes a. Okay, so a and a will get cancelled, h will approach 0. Fine. Changing limits concept we have applied over here. So limit h approaches 0, sine a plus h minus sine a upon root a plus h minus root a. Now these things are quite complicated over here. In the denominator, I'm going to take conjugate, root of a plus h plus root a, multiply and divide. I'll multiply and divide with the conjugate. In the numerator, I'm going to apply sine c plus sine d formula. So sine c minus sine d is equal to 2 cos c plus d by 2 into sine c minus d by 2. We are applying factorization formula in the numerator, where c is a plus h, d is a. Okay, so this will be limit h approaching 0 to cos c plus d. So this plus a upon 2 sine this minus a upon 2 upon root of a plus h minus root a. So take the conjugate of this, root of a plus x plus root a, root of a plus x plus root a. So this is x minus y into x plus y, which is x square minus y square. So denominator is quite sorted over here. Okay, in the numerator, this entire thing will be cos 2a plus h by 2. Okay, and here sin a will go sin h by 2. So this will be sin h by 2. Okay, root a plus x, a plus h. I'm sorry, the conjugate part I've written plus x by mistake. It's a plus h. So root a plus h plus root a upon root a plus h the whole square minus root a the whole square. So down I have written x square minus y square. Okay, so first two terms will remain as it is. So limit h approaching 0 to cos 2a plus h by 2 upon into sin h by 2 sin h by 2 root of a plus h plus root a. And down it is a plus h minus a. Okay, so we are left with only h term. Okay, now this h term will be given to sine term. Okay, so the angle over here is h by 2, so down also will make h by 2 twice h by 2 2 cos 2a plus h the whole upon 2 sin h by 2. Okay, divided by h, and this is root a plus h plus root a. So here we'll multiply and divide with 2. Purpose is we can apply the formula for sine then. So sine h by 2 upon h by 2. Sine h by 2 upon h by 2. H is approaching 0, so it is 1. And wherever there is x in the rest of the terms, wherever there is h, wherever there is h, I'm going to put 0. Direct value substitution. So 2 cos 2a plus 0 upon 2. Fine. Sin h upon h by 2 is 1. Down there is 2. So 1 upon 2 into root of a plus 0 plus root a. Okay. So 2 cos a. This will be a, right? Into half. This 2 and this 2 also, let's cancel it out. Into root a plus root a is 2 root 2a. So the answer is 2 root 2a cos a. Fine. 9 sum for you all. Question number 9. As I can see, 1 plus sec cube x upon tan square x is given. You can apply changing limits if you want, but then I'll apply a cube plus b cube in the numerator, and down it is tan square x. So tan square x, apply fundamental identity and then expand it. So 1 plus sec cube x is equal to sec square x minus 1. Okay, and in the numerator also I'll change the order. I'll write sec cube x plus 1. So in the numerator I'm going to apply a cube minus b cube, denominator a square minus b square. So this is equal to limit x approaching towards pi, sec x plus 1, sec square x plus sec x into 1, that is sec x plus 1 square. 1 square is 1 upon sec x plus 1, sec x minus 1. These two terms are getting cancelled. Now if you put pi over here, x as pi. So sec pi, that is sec 180. Sec pi is equal to sec 180. Okay. So cos 80 is minus 180 is minus 1. So this is equal to 1 upon cos 180. So 1 upon minus 1, answer is minus 1. So down, see, after substitution of x as pi, we are not getting 0. We are getting minus 1, minus 1. So minus 1 is minus 2. So let's put the value of x as pi everywhere. So sec square pi plus sec pi plus 1 upon sec pi minus 1. Sec pi minus 1. Okay, just a second. Should be this way. Yeah, sorry. Now sec pi value we have already calculated. Sec 180, which is minus 1. So minus 1 the whole square plus minus 1 plus 1 minus 1 minus 1. Okay. So 1 square is 1 minus 1 plus 1 upon minus 2. So the answer is minus 1 upon 2. Okay. Fine. So let us go to the previous slide. See, I have applied a cube plus b cube. Acha, a cube plus b cube, I think I have made one small error over here. It is a plus b a square minus ab plus b square. So I have not put a minus sign over here. So I just make that change. So this is also minus over here. This is minus over here. So 1 plus 1 upon plus 1 upon minus 2. So this is minus 3 by 2. Minus 3 by 2. So that was exercise 16, sorry, 18H from your chapter limits.